Hello, and welcome to this lesson on noble gases. In today's lesson, we will understand the properties of noble gases, including their lack of reactivity and stable electron configurations. We will recognize the significance of their position in group 0 of the periodic table. So far, we've explored electron configurations and the periodic table. You have gained a good understanding of how electrons are arranged in atoms and how this arrangement influences the chemical properties of elements. Building on this foundation, today's lesson will delve into the unique characteristics of noble gases, highlighting how their chemical properties arise from their stable electron arrangement. To understand the properties of noble gases, let's explore their distinctive characteristics and why they are unique. Noble gases are the elements located in group 0 of the periodic table. This group includes the elements helium, neon, argon, krypton, xenon, and radon. At room temperature, these elements are all colorless gases. One of the most notable properties of noble gases is their lack of reactivity. They are often referred to as inert gases because they do not readily engage in chemical reactions with any other elements under standard conditions. This lack of reactivity is crucial in understanding their behavior and uses. Now let's have a look at the significance of noble gases' position in group 0. The reason behind their chemical inertness lies in their electron configurations. Atoms of noble gases have full valence electron shells, meaning their outermost energy levels are completely filled with electrons. To break it down further, let's look at what it means for an atom to have a full valence shell. Firstly, these noble gases have stable electron configurations. Atoms typically strive to achieve a full valence shell because it results in a more stable, lower energy state. For an atom to fill its outer shell, it might gain, lose, or share electrons when forming chemical bonds. However, since the noble gases already have full outer shells, they do not need to engage in such behavior to achieve stability. Secondly, these noble gases also have an inability to form bonds easily. Because their electron shells are complete, noble gases do not have a tendency to gain or lose electrons. This makes it difficult for them to form chemical bonds with other elements. They rarely donate or accept electrons from other atoms. Some other properties of the noble gases include their lack of flammability, which is linked to their inertness, and their low densities. We will delve into how these properties link to their real-life uses in a later lesson. In conclusion, noble gases, comprising elements such as helium, neon, argon, krypton, xenon, and radon, are characterized by their colorless appearance and remarkable lack of chemical reactivity. This inert nature is a defining feature that significantly influences their behavior and applications in various fields. In summary, the chemical inertness of noble gases, due to their full valence electron shells, prevents them from easily forming chemical bonds with other elements. This unique property contributes to their lack of reactivity, which, along with other characteristics like low flammability and low densities, influences their practical applications. This lesson has provided a comprehensive overview of the properties of noble gases, their place in the periodic table, and their practical uses, laying the groundwork for further exploration of chemical elements and their behaviors.